Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. We analyze each compound systematically for stereocenters, planes of symmetry, meso, and axis of chirality. Concept background. For n stereocenters, maximum to n stereoisomers. Meso compounds are achiral due to internal symmetry despite having stereocenters. Each enantiomeric pair consists of two non-superimposable mirror images. Total stereoisomers is equal to 2 asterisk, number of enantiomeric pairs plus number of meso compounds. A. Proxenic acid 1, 2-diphenyl 3,4 cyclobutanidicarboxylic acid 1, 2 arrangement. The cyclobutane has substituents at C1, pH, C2, CO2H, C3, pH, C4, CO2H in a 1, 2, 3, 4 pattern. There are 4 stereocenters. Maximum is equal to 4 is equal to 16, but ring constraints reduce this. After accounting for ring geometry and internal symmetry, there are 10 stereoisomers total, 4 enantiomeric pairs, 8 chiral isomers, and 2 meso compounds. A is equal to 10, B is equal to 4, C is equal to 2. B. Truxylic acid 1, 2-diphenyl 3,4 cyclobutanidicarboxylic acid 1, 3 head-to-head arrangement. Cyclobutane with pH at C1, C3 and CO2H at C2, C4. The molecule has a high degree of symmetry. With 4 stereocenters but extensive symmetry constraints, there are 5 stereoisomers, all meso, due to the symmetric substitution pattern creating internal mirror planes in every stereoisomeric form. No enantiomeric pairs exist. A is equal to 5, B is equal to 0, C is equal to 5. C. Fused bicyclobutane with CO2H and Cl. To stereocenters, the carbons bearing CO2H and Cl. With ring fusion constraints, 4 stereoisomers are possible. To enantiomeric pairs, no meso forms. The 2 stereocenters bear different substituents, so no internal mirror plane. A is equal to 4, B is equal to 2, C is equal to 0. D. Spiro compound with 4 close atoms, 2 on each spirocarbon. The spirocarbon itself and the 2 Cl-bearing ring junction carbons. The compound has axial chirality at the spiro center. 2 stereocenters giving 4 maximum, but symmetry reduces to 2 stereoisomers forming 1 enantiomeric pair, no meso. A is equal to 2, B is equal to 1, C is equal to 0. E, C, CH3CHCl, 4. Central quaternary carbon with 4 identical CH3CHCl groups. Each CHCl is a stereocenter, 4 stereocenters. Maximum is equal to 4 is equal to 16, but because all 4 arms are identical, many are equivalent. The distinct stereoisomers are R, S, 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 enantiomeric pair, R, S, 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 R, enantiomeric pair, and R, S, S, mesoform. That gives 5 stereoisomers, 2 enantiomeric pairs and 1 meso. A is equal to 5, B is equal to 2, C is equal to 1. F, 1, 2, dichloro 4 carboxycyclopentane. 3 stereocenters, C1, Cl, C2, Cl, C4, CO2H. C1 and C2 are related by ring symmetry. Maximum is equal to 3 is equal to 8, but symmetry reduces this. The CIS-trans relationships at C1, C2 and relative configuration at C4 give, when C1, C2 are CIS they form a meso-like pair, when trans they are chiral. Analysis yields 4 stereoisomers, 1 enantiomeric pair and 2 meso compounds. A is equal to 4, B is equal to 1, C is equal to 2. G1,2-dichloro-4-carboxymethylidene cyclopentane. The exocyclic double bond is equal to CHCO2H creates EZ isomerism plus C1Cl and C2Cl stereocenters. Two ring stereocenters plus EZ is equal to effectively 3 sources of stereoisomerism. This gives 4 stereoisomers total. To enantiomeric pairs, no meso, the EZ double bond element breaks the symmetry that would be needed for mesoforms with these substitution patterns. A is equal to 4, B is equal to 2, C is equal to 0. H1,2-dichloro-4-alenic chain with CO2H cyclopentane. The alenic is equal to C is equal to CHCO to H introduces axial chirality plus the 2 ring Cl stereocenters. With 3 sources of stereoisomerism, C1Cl, C2Cl, alenic axis, symmetry analysis gives 4 stereoisomers, 1 enantiomeric pair and 2 meso compounds, when the ring Cl groups are in configurations that create internal symmetry with the alenic axis. A is equal to 4, B is equal to 1, C is equal to 2. Therefore, the correct answer is A 10, B 4, C 2, B A 5, B 0, C 5, C A 4, B 2, C 0, D A 2, B 1, C 0, E A 5, B 2, C 1, F A 4, B 1, C 2, G A 4, B 2, C 0, H A 4, B 1, C 2. The correct answer is shown on screen.